Most people wait for things to go wrong before fixing them. Machines break, customers complain, shipments get delayed, and only then do teams scramble to find out what happened. But what if you could predict those problems before they ever reach your customer? That's exactly what FMEA helps you do. It's a method that lets you look into the future, not by guessing, but by systematically uncovering weak spots in your process so you can prevent failure instead of reacting to it. And if you're working toward your Six Sigma certification, mastering FMEA is a major step in learning to think proactively, not reactively. FMEA stands for Failure Mode and Effects Analysis. It's a structured way to identify what could go wrong in a process, product, or service, how severe the impact would be if it did go wrong, and how likely it is to happen. In simple terms, it's a preventive checklist backed by logic and prioritization. The goal is to find the biggest risks before they find you. FMEA was originally developed by the aerospace and automotive industries, where failure could mean catastrophic loss. But today, you'll find it used everywhere, from hospitals to tech startups, because it helps any team design stronger, more reliable systems. Let's translate the jargon. A failure mode is just a fancy way of saying how something could fail. The effect is what happens when it fails, and the analysis is how we rank and decide which risks to tackle first. It's part of the Six Sigma toolkit used in the analyze and improve phases of DMIC. Define, measure, analyze, improve, control. It forces you to think ahead by asking three essential questions. What could fail? What would happen if it failed? And how can we prevent that failure? Imagine a small medical device manufacturer that produces electronic thermometers for hospitals. Recently, one customer reported that a batch of thermometers displayed inconsistent readings. Instead of waiting for more complaints, the quality team decided to conduct an FMEA on the assembly process. They gathered engineers, operators, and inspectors in a room, people who knew every detail of how those thermometers were built. The team started by mapping out each step of the assembly process, from soldering the circuit board to packaging the final product. At each step, they asked, what could go wrong here? For soldering, they identified several failure modes: cold joints, incorrect component placement, and overheating the board. Then they listed the potential effects of each failure. A cold joint might cause the device to fail completely. Misplaced components might lead to incorrect temperature readings. Overheating could weaken the sensor's accuracy. Next, they ranked each failure by three factors: severity, occurrence, and detection. Severity measures how bad the outcome would be if it happened. Occurrence measures how often it might happen. Detection measures how likely you are to catch it before it reaches the customer. Each factor gets a score, and when you multiply them, you get what's called an RPN, or risk priority number. The higher the number, the higher the priority to fix that failure. In our example, the team discovered that overheating during soldering had the highest RPN. It wasn't happening all the time, but when it did, it caused serious accuracy problems that weren't easily detected in testing. With that insight, the engineers reviewed the soldering temperature controls and found they fluctuated slightly depending on the operator's technique. They installed an automatic temperature controller, added a visual indicator for when the iron exceeded limits, and retrained the operators. A simple change eliminated a high-risk failure mode before it reached another customer. That's the beauty of FMEA. It makes invisible risks visible. It helps you allocate your time and resources where they'll have the biggest impact. Instead of guessing what might go wrong, you use structured thinking to anticipate it. And over time, that mindset builds more stable, predictable processes, the very essence of Six Sigma. Of course, like any tool, FMEA comes with pitfalls. One common mistake is treating it as a one-time paperwork exercise instead of a living document. Teams often fill out the FMEA form, assign a few scores, and move on. But processes change. New equipment, new materials, new people, and so should your FMEA. It's not just a form to file. It's a risk map that should evolve with your business. A good practice is to revisit it regularly, especially after any major process change or quality issue. Another trap is letting the scoring system become too subjective. People sometimes argue endlessly over whether something is a 5 or a 6 on severity or occurrence. The numbers aren't the point. The discussion is. The power of FMEA lies in the conversation it sparks, the shared understanding it builds, and the actions it drives. Use the numbers as a guide, not a verdict. There's also a danger in overcomplicating the process. Some teams dive too deep, trying to document every single possible failure, no matter how trivial. That quickly becomes overwhelming. The key is focus. Start with the most critical process steps, where failure would cause the greatest harm to the customer or the business. Then expand gradually as you gain experience. And finally, the most damaging pitfall is ignoring the results. Teams spend hours creating a thorough FMEA, identify clear risks, and then never act on them. That defeats the entire purpose. The A in FMEA stands for analysis, but what makes it powerful is action. Once you've identified high-risk areas, take tangible steps to reduce those risks. Add controls, redesign processes, or improve training. Only then does FMEA deliver its full value. One of the most rewarding aspects of learning FMEA during your Six Sigma certification journey is how it transforms your thinking. You stop reacting to problems and start anticipating them. You begin to see that most failures don't come out of nowhere. They leave clues long before they appear. FMEA teaches you to look for those clues and act before customers ever feel the pain. It's a discipline that blends engineering logic with human judgment, data with intuition. In service industries, FMEA works just as well. Imagine a bank rolling out a new online loan application system. They can use FMEA to identify potential failure modes like incorrect data entry, system downtime, or delayed approval notifications. Each of those can be analyzed, prioritized, and mitigated before launch. That proactive approach prevents headaches for both customers and employees. FMEA also fosters collaboration. It brings people from different departments together to look at the same process through different lenses. Engineers think about design, operators think about workflow, and quality staff think about detection. That mix of perspectives leads to solutions that no single person could have created alone. The biggest lesson FMEA teaches is humility. No process is perfect, no system immune to error. But when you use FMEA, you admit that things can fail, and you prepare for it. That's not pessimism, that's professionalism. And it's exactly the kind of mindset that distinguishes a Six Sigma professional from an average problem solver. The takeaway is simple. FMEA helps you build reliability into your process before failure ever happens. It's like having a safety net made of foresight instead of reaction. For anyone pursuing Six Sigma certification, mastering this tool means you're no longer chasing problems, you're preventing them. So next time you start a new project or redesign a process, grab an FMEA template and gather your team. Walk through each step, ask what could go wrong, and decide what matters most. You'll be amazed how many potential headaches you can eliminate before they ever exist. That's the difference between putting out fires and building a fireproof system. And that's what Six Sigma is all about.